Hello and good afternoon, everyone. I welcome you all to India's largest e-learning platform, Unacademy, and I welcome you all to my session of Antenna CTQ series. I welcome you all to the GATE Conqueror channel. We are into the very important concept through question series, and today in this particular session, part 8, we're ready to learn some extremely good concepts that will be useful in understanding of wave propagation or field theory. Before we do that, let me introduce myself. I am G Reddy. Having 15 plus years of experience in teaching, guiding and mentoring GATE and ESE aspirants. I work as motivational speaker pan-India from the past 12 years, expert in field theory and communications. This is the official link where you can join us on Telegram. The advantage of joining us on Telegram is that you get a personal level support from all the faculties of the GATE Conqueror channel. The good thing that all we know now is 4 more new educators added to our channel. And we are going to rock the sessions, dear. We are determined as a team. We are determined to finish the syllabus for GATE 2023 and ESE 2023 comprehensively. And my part in it is to complete 3 important subjects. 1, EMFT for ECE and EMF for EEE. I take this responsibility to complete EMFT for ECE and EMF for EEE for both GATE and ESE. And I take this responsibility to complete communications for ECE and communications for electrical. This is for GATE and this is for ESE. I take the responsibility to complete advanced communications for ECE. This is for ESE, engineering services. So all these subjects are my responsibility here. Just stay tuned to get all the updates of what all subjects we are supposed to finish, we are planning to finish on this wonderful channel. Unacademy offers two paid platforms. One is Plus subscription, other is Iconic subscription. In Plus subscription, we have live classes, weekly test, structured courses, unlimited access, rank improvement batches and crash courses. Iconic We have all the features of the Plus subscription. Along with that, you have a personal coach, one-on-one guidance, dedicated doubt clearing educators to clear your doubts within 24 hours, preparatory study material, personalized test analysis, study booster sessions, and study planner. Remember, iconic subscription includes all the benefits of Plus subscription. Whether you take Plus subscription or iconic subscription, I recommend you to go for a no-cost EMI. The total cost will be divided by number of months without any extra charge. Moreover, you can use our team code KNR10 to avail extra 10% off. With iconic subscription, 1:1 live mentoring, improving your chance of getting a top rank. Take your preparation to next level by using GATE and ESE iconic subscription. What all benefits that you have through iconic subscription, I'll try to explain. You'll be having a personal coach for one-on-one guidance or 1:1 live mentoring, online study material, priority in Ask a Doubt, live doubt solving sessions, study booster sessions, priority in live classes using raise a hand option, open house with educators, community learning, and also we can avail all the benefits of Plus subscription. Do not ignore this, dear. We have an offer for Plus subscription. With every 12-month subscription, we are giving away 2 months subscription extra. With every 24-month subscription, we are giving away 3 months subscription extra. This offer is valid till tomorrow. To subscribe, you can use our team code KNR10 to avail extra 10% off. Free physical notes, GATE iconic, 1 year and above subscribers. The notes will be delivered to you or will be disbursed in the last week of the May. These notes are curated by India's topmost educators, having comprehensive syllabus coverage, solved examples to build problem-solving skills, available for electrical, EC, mechanical, civil and computer science. Try to avail this opportunity, dear. Having a standard note is a very important point in your success story for GATE. You can easily crack 2023 or 2024 GATE with the help of Unacademy Lite subscription, which is a mix of topic and subject-wise mock test. You'll also get access to structured test series. See, test series or writing test is a very important thing, dear. Do not straight away go and write the exam. See, what people do is like around 70% of the people or around 70% of the students. Good evening, Bhaskar. Good evening, Anil. Around 70% of the students, what they do here is, they simply straight away go and try to write the exam. That means they don't have any hands-on practice now. They are facing the actual gate exam directly in the final exam itself. Now you tell me, is it possible for you to manage the time? You are attempting the exam directly. Unbelievable. Two things you will not understand. How to deal with the format of the exam, you are not sure. Second is time. How much time will be sufficient for you? Or within the given time, how many questions you can attempt? You are not sure. You are also not sure that how many questions you need to attempt to get a good rank. There is a lot of ambiguity in you. If you go to the exam directly, that's a very risky thing to do, dear. The probability of you getting success is very, very less. So never ever do this. You take any successful student here. You take any successful student. One thing you can find very common in them is like they would have written already minimum of 40 mock tests. Writing test series or mock tests is a very important part of strategy to get a top rank. No matter how intelligent you are, dear, the probability of getting rank is very, very less without writing a test series. Please mark my word out of experience. Do not ever try to write the exam directly. Very dangerous thing to do so. Got it, my dear friends? It's very, very dangerous thing to do. And this Unacademy Lite subscription will help you out in this most important part of preparation, that is writing test series. And we provide you a standardized test series because these test series are designed by IITians. The alumni of IIT will design test series for you. So naturally it will be of a very high standard. And dear, I am going to tell you one thing, dear. There won't be any much difference between your test series score and the final score. The maximum variation that you can expect is around 5 to 10%. Do not expect a lot of variation, a big variation between your test series results and the final results. Please mark my words, dear. Therefore, this Unacademy Lite subscription is a very important factor which plays a pivotal role in your success. This is Unacademy Ask a Doubt feature, dear, through which you can ask unlimited number of doubts. Through which you can ask unlimited number of doubts. Available both on app and website. At a go, you can ask 3 doubts. 1 second here. I'm just trying to hide this video for few seconds. And get a solution in your preferred language. And remember, it is very easy to ask your doubt. Just click crop and submit. It's very easy to ask your doubt. Get in touch with our counselor. If you are confused about the preparation journey, if you are having curious about subscriptions, or if you want to know about the latest offers, you are just a call away to get the suggestion from our counselor. This is the number that you need to dial for the same. These are special class features, which includes interactive live classes, polls for the learners. See, polls are also a very important thing there. It's a proven thing that polls are the most effective ways of learning. It builds up curiosity among the learners, a healthy environment among the learners. So all our special class include these polls. You also have a raise hand option. This online education, having raise hand is a very important that we do not have on platforms like YouTube, I'm right? You cannot raise your hand. I can speak to you, but you cannot speak to me directly. Of course, you can communicate it through the chat box. Hello and good evening, Srikant Tiwari. But this wonderful raise a hand option is available where you can speak directly with the educators and share your doubts with the educator. That's a wonderful feature that we have where we can avail the voice interaction between the student and the educator. This is one of the unique features that we have once you attend special classes on our app. And you never miss a class once the notification is on. So I recommend you to follow my profile on the app so that you never miss any class, because we people will send you notification 10 minutes before the class. And also the important feature that we have is you can download the lecture notes after the class is done. So it's not like you need to concentrate on my lecture and write both at a time. You need not do that both at a time. You can concentrate and write some short note or something while you are trying to attend my class. And after the class is done, whatever I write in this PPT will be available for you as a PDF. That's a wonderful thing, am I right? You can pay your utmost attention on the class. So that feature you try to avail. You can download the lecture notes after the class is done. And of course you can access anytime and anywhere, because there the class is done through app. Just download the app and you can access them anywhere and anytime. There's a lot of learning procedure, learning methodologies that are available to learn through the special classes. Try to avail this opportunity of learning through special classes, dear. My next special class will be tomorrow 10 a.m. So just follow my profile so that you get regular updates about my special classes. You can type my name and follow the profile so that we will send you regular updates. And in these special classes, this is my name, dear, G Chaitanya Reddy. You can follow my profile by searching through my name. And we have some wonderful series of advanced communication previously taken on special classes. I can say here it was something like never before. Very in detailed, comprehensive way of understanding advanced communication, the theory, the derivations, the practice questions, the previous year questions, what not, dear. We have dealt this so elaborately, on the special classes. You can go through this advanced communication series. It is available still on the app. These are the new batches here, which is WARANGAL GATE 2024 for electrical explained in English, and will start today. Will be started by B. Reddy sir at 6 p.m. by starting with EMFT. and by Archit Kamath sir, studying control systems at 8:30 p.m. This is batchy for the web. You can use the code KNR10 to avail extra 10% off. This is Spare Gate 2023. Again, batchy for electrical, explained in English. Will start today. Again, started or handled by B.V. Reddy sir with EMFT at 6 p.m. and Archit Kamath sir with control systems at 8:30 p.m. You can use the code KNR10 to avail extra 10% off the hour. Yes, dear. Yes, is that clear? Then we have the verb Gate 2024 batch. Batchy for ECE explained in English will start today. And B.V. Reddy sir will handle EMFT at 6 p.m. and Archit Kamath sir will start with control systems. You can use the code KNR10 to avail extra 10% off the hour. This is Spark batch for Gate 2023 for ECE explained English will start April 13, 2022. That is today. Again, B.V. Reddy sir will handle EMFT and Archit Kamath sir will handle control systems at 6 p.m. and 8:30 p.m. respectively. You can use the code KNR10 to avail extra 10% off the hour. This is our team code where you can avail extra 10% off. Any doubts you can ask here. We are into the antennas CTQ series. Concept through question series. Which is part of EMFT. As I told you, I'm shouldered with this responsibility to complete EMFT for GATE 2023 and ESE 2023. This EMFT subject has 5 modules into it. With module 1, elements of EMF theory. With module 1, elements of EMF theory. Yeah. See, anything is there you can ask. Any doubt is there you can ask dear. Need not feel shy. The more you ask me questions, the more interactive this class will become dear. So try and ask more questions to me. So that we can have that communication rolled up and going on. Module 1 is elements of EMF theory. Common for ECE and electrical. We have created a wonderful playlist on this day. 40 hours and 40 videos and 50 hours of content. Useful for ECE and electrical. And useful for exams like GATE and ESE. And of course other competitive exams also. This is a wonderful playlist here. Because as far as I know, for elements of EMFT theory, which is the complete syllabus for electrical, a part of the syllabus for ECE, the maximum number of hours that you can expect is no more than 10. Against that, we got some 50 hours of content here. So I'm very confident that this particular playlist will be useful pan-India for all the students, which will also inculcate lot of confidence among the students in the process of preparation of EMFT. So that's module 1, elements of EMF theory, both EC and electrical. And the playlist is created with 40 videos and 50 hours of content such that it is useful for both GATE and ESE. Yes. What is module 2, dear? Anyone? What is module 2? What is module 2? Module 2 is EM wave propagation. Module 2 is EM wave propagation. In this, we understand how EM waves are propagated through different mediums. We had created a playlist for this too. With 15 videos and 30 hours of content. Once again, for EM wave propagation, the maximum content that I had seen on any YouTube channel was not more than 8 hours. Against that, already we have 30 hours of a playlist and only 90% of the syllabus is done. Still, reflection and refraction of plane waves, normal and oblique incidence with perfect conductor and perfect dielectric are left out, where we study concepts like critical angle, total internal reflection and Brewster angle. Brewster angle is a case of incident angle where reflected wave is 0. Total internal reflection is a case where transmitted angle is 0. So very interesting topic here that we'll try to deal as reflection and refraction of plane waves. Module 2, 90% is done here also. Module 3 we'll start very soon. That is transmission lines. And module 4 is waveguides. These two are very hefty topics. We need to do a serious analysis of these modules. We cannot start it in a hurry. When this is done, module 2 EM wave propagation, parallelly I will be starting transmission lines. And module 5, a mix of two things, optical fiber communication and antennas. Optical fiber communication again is a separate series which I'll take. We're taking 8 to 10 hours for sure. Regarding antennas, we have a playlist named with Antennas Mahamarathon series, where we have 18 videos, 38 hours of content. So overall number of hours that we had already got it in through this is module 1, 50 hours of content. Module 2 with 30 hours of content and 10% left out. Module 3, transmission line yet to start. Module 4, waveguides yet to start. Module 5, OFC and antennas. As I told you, OFC will take a separate series. For antennas, we got antennas Maha Marathon series. Total of 38 hours of content. So right now we have 108 hours of content only for EMFT. 112 more hours. I'm trying to plan to make it a grand 220 hours syllabi for EMFT. So this is the overview of the different kinds of modules that we have in EMFT. Let us start our discussion with module 1. Elements of EMF theory. Common for EC and electrical. For electrical, it's a complete syllabi. For EC, it's a part of the syllabus. Clear? Then see module 2. Basics. 2. Static field theory. 3. Time varying field theory. Time varying field theory. Okay. So basics, static field theory and time varying field theory. Under basics, we have 2 parts into it. Elements of vector calculus. Is one part. And coordinate system is one more part. Under elements of vector calculus, we have discussed topics like scalar. What is a scalar, dear? A scalar is one which has only magnitude but no direction. Yeah, good evening, Karna. A vector is one which has both magnitude and direction. Unit vector will always gives you the direction of the vector. Then we had seen addition of vectors. It's in addition of vectors. Under addition of vectors, we have seen parallelogram law, and head to tail rule. Head to tail rule is also called as triangular law. Then we had seen basic laws of vectors. Under basic laws of vectors, we have seen commutative law, associative law, and distributive law. The commutative law, commutative law of addition, which is for any two vectors, a plus b is equal to b plus a. Commutative law of multiplication, for k is a scalar, a is a vector, k into a is equal to a into k. We have seen associative law, a plus of b plus c is equal to a plus b plus c. Similarly, k is a scalar, l is a scalar, a is a vector, k into la is equal to k into l into a. Distributive law, k into a plus b is equal to ka plus kb. We have seen these basic laws of vectors and also discussed on this in depth. There is no distributive law of multiplication. Why there is no distributive law of multiplication? I explained very clearly in the playlist. Please go through it. Then we had seen multiplication of vectors, multiplication of vectors. Under multiplication of vectors, let's see dot product, also called as scalar product. Let's see cross product, also called as vector product. And also we had seen dot product obeys which basic laws and cross product obeys which basic laws. This is a very interesting concept here. Please go through the playlist for understanding of multiplication of vectors, because basically understanding multiplication of vectors is a very important thing for understanding or better understanding of EMF. Then we had seen the most important quantity called del and its properties. In Cartesian coordinate system, this del is defined as dou by dou x of x plus dou by dou y of ay plus dou by dou z of az. Del is called as vector differential operator. Del is called as vector differential operator. Vector differential operator, because it's a vector in itself. What it does is differentiation. It is also called as spatial derivative operator, because what it is doing is the derivative with respect to spatial coordinates x, y, z. So this is what is del is. It's a special operator, and we had seen the properties of del. Mainly we had seen del when operated on a vector, del dot A is called divergence of A. Divergence, del is a vector, A is a vector, dot product of any two vectors is a scalar. So divergence of any vector is a scalar quantity. If that divergence is 0, then A is said to be divergence less vector, or solenoidal vector. If the divergence is positive, then A is said to be source. If the divergence is negative, A is said to be sink. Similarly, when del operated on a vector using a cross product, del cross A is read as curl of A or orientation of A, which is a vector quantity. Del is a vector, A is a vector, cross product of two vectors is one more vector. If this orientation is 0, rotation is 0, then A is said to be irrotational vector. Of course, in playlist I have given some beautiful examples also related this to our subject. So please go through the playlist for in detailed explanation of this. It is not equal to 0, then there is some rotation. It's called rotational vector. For each of this, we have some very beautiful examples that are given in the playlist. Please go through it. When this del operated directly on a scalar, it's called gradient of the scalar. Gradient of V. Gradient of any scalar is a vector quantity. Again, some beautiful examples are given for this case also. So these are the properties here. And other than del and its properties, we have seen vector identities. What are the vector identities that we have seen? Two main vector identities we have seen. Divergence of del dot, curl of any vector is 0. Second, curl of gradient of any scalar is 0. Scalar, vector, unit vector, addition of vectors, basic laws, multiplication of vectors, del and its properties, and vector identities. All these topics together will make elements of vector calculus, the first part of basics. Second part of the basics is coordinate system. Let us see what we have discussed under coordinate system, and I recommend you to please go through the playlist for in detailed analysis of these basics. The more clearly you understand these basics, subject will become that much easy for you. Under coordinate systems, what we have discussed, let us see once. Under coordinate system, we have seen types of coordinate system. We have seen types of coordinate system. In types of coordinate system, we had seen Cartesian coordinate system, cylindrical coordinate system, and spherical coordinate system. What are this Cartesian coordinate system called here? What was this Cartesian coordinate system called? Cartesian coordinate system is also called as rectangular coordinate system, cylindrical coordinate system is also called as circular coordinate system. What are the coordinates here? Cartesian coordinate system, coordinates x, y, z. Cylindrical coordinate system, coordinates rho, phi, z. Spherical coordinate system, coordinates r, theta, phi. And what is range? If you go for x, y or z, its range is from minus infinity to plus infinity. This is for Cartesian coordinate system, all the coordinates ranging from minus infinity to plus infinity. And if you go for cylindrical coordinate system, rho is the radius of the cylinder from 0 to infinity. Phi is the azimuthal angle from 0 to 2 pi. And Z is the length of the cylinder minus infinity to plus infinity. You go for spherical coordinate system, R is the radius of the sphere, 0 to infinity. Theta is the co-altitude angle, it's from 0 to pi. And phi is the azimuthal angle, which is 0 to 2 pi. And you may ask me, dear, sir, why these ranges are in this way? Please refer the playlist, dear. For this answer, please refer the playlist. Once you refer the playlist, you get a good idea of why these things are in this way. A detailed explanation of why these coordinates are in this way and why these ranges are in this way. I explained very, very detailedly. So I request you people to go through the playlist so that you will get the clarity. Hi, dear. Is that clear? One second. Yeah. Yeah. Any doubts you can ask, dear? Anyone, any doubts you can ask? Fine. Then we had seen point transformation, how to convert a point from one coordinate system to another coordinate system. It's a beautiful topic, this one. Then we had seen unit vector relations. This unit vector relations, we understood how to interconnect the unit vectors of three different coordinate systems, like from Cartesian coordinate system Ax, Ay, Az, from cylindrical A rho, A phi, Az, from spherical AR, A theta, A phi. How to interconnect them has been explained very beautifully in this unit vector relations. Then we have seen how to write the differential length, differential surface and differential volume in all the three coordinate system. And also we got the shortcut for the same. The shortcut formulas are also very, very important here, which we discussed in the basic concepts. Then we had seen how to write divergence, curl, gradient and Laplacian in all the three coordinate systems. And also we designed the shortcut. Very, very, very important topic. Around 15 hours of lecture we took for this to cover only basics, dear. That's why it's very, very important. And that's the key actually. That is what differentiates our particular playlist from the other playlist. In other playlists, maximum elements of EMF theory will be 8 to 9 hours, where we covered only basics for 15 hours. We covered only basics, taking 15 hours of lecture. This is the key point which differentiates our playlist from the other playlist, and it becomes very easy for you after this to understand the rest of the concepts. Second part, static field theory. In static field theory, we had covered topics like Coulomb's law. What is Coulomb's law, dear? Coulomb's law will deal with force between the point charges, and this is a generalized law that governs electrostatics, and we had seen applications of it. In applications, we had seen line charge, surface charge, and volume charge. And some very good derivations we had done that will be useful for engineering services. The formulas and the shortcuts will be useful for GATE and other competitive exams. So we had dealt this topic, in not only this, each and every topic in such a way that it will be useful for both GATE and ESE and other competitive exams simultaneously. Then we went for Gauss Law. Gauss Law is a special law that governs electrostatics. It can be applied only on Gaussian surfaces, and a Gaussian surface is one which is symmetric with respect to charge distribution. We had seen applications of Gauss Law. In applications of Gauss Law, we had seen point charge, line charge, surface charge, and volume charge. Very, very, very important topic for both GATE and ESE. And we had done some numerous number of problems on this, dear. You will be just wondered to see so many number of problems, all PYQs, literally all PYQs of GATE and ESE, hundreds of practice questions only on Coulomb's and Gauss Law we had done. Then we went for electric potential. That is nothing but EMF, electromotive force, voltage. Then we derived the derivation for this voltage or EMF or electric potential. Then we had seen relation between E and V. How E and V are interrelated. Very, very important formulas again. Only the most important topics I am trying to highlight here. These topics were dealt under electrostatics. Then under magnetostatics, static magnetic field theory. We have seen the generalized law that governs magnetostatics, just like Coulomb's law governs electrostatics, with the generalized law that governs electrostatics. We have seen Biot-Savart law, the generalized law that governs magnetostatics, and we had seen its application over line current. Also, we had seen the application over line current. Okay. That is about Bayard-Savart law. And we have seen the applications of Bayard-Savart law. Bayard-Savart law is just like Coulomb's law, is a generalized law that governs magnetostatics. We have seen these applications over line current. Just like we have Gauss law, which is the special law that governs electrostatics, we have Ampere's law here, which governs magnetostatics, Ampere's law or Ampere's circuit law, and we have seen its applications over line current, surface current and volume current. Again, very important concepts here. Just like we have derived electric potential or EMF here, we derived scalar magnetic potential. Scalar magnetic potential or MMF. But there is a problem with MMF, dear. Can anyone tell me? What is the problem with MMF? What is the problem with MMF? Not defined means what? Not defined means magnetomotive force is not defined in regions where sigma is 0. I mean to say, magnetomotive force is not defined in the region where sigma not equal to 0 or sigma exists or conductivity exists. Scalar magnetic potential is only defined in the regions where there is no conductivity or sigma is 0. Like free space and vacuum. Whenever sigma exists, MMF cannot exist. There is also a beautiful derivation there, a logical concept that we are explained in the playlist. Please go to the playlist to understand why MMF cannot be defined in all the regions. It can be defined only in the regions where sigma is 0. Whenever sigma is not equal to 0, it fails. This concept is called failure of MMF. This is called failure of MMF. As this fellow is failing, in certain conditions we define vector magnetic potential given by symbol A, unit Weber per meter. Work done per current element formula. We have seen relation between A and B. Relation between A and B. Just like we got relation between E and B here, we got relation between A and B here. A is vector magnetic potential and B is magnetic flux density. You can see the similarities here. This is generalized law, this is generalized law, this is special law, this is special law. This can be defined on Gaussian surface, this can be defined on Amperian path. We have seen applications in all these cases. This is electromotive force voltage, EMF, this is MMF, current. Relation between E and B, relation between A and B. Actually, we need to study into this particular thing in this way. A comparative study will make things easy and you will be ready for competitive exams. And other than this, we also dealt some common topics. Under common topics, we discussed about work done. Common means both for electrostatics and magnetostatics. Work done in electrostatic field and work done in magnetostatic field. Energy density, both electrostatic field and magnetostatic field. We derived Poisson's and Laplace equations. For both electrostatic fields and magnetostatic fields. Poisson's and Laplace equations for both electrostatic and magnetostatic fields. We derived boundary conditions. Both electrostatic fields and magnetostatic fields. In electrostatics, we derived capacitors and types, in which we have derived parallel plate capacitor, cylindrical capacitor and coaxial cable capacitor, and spherical capacitor. Parallel plate, cylindrical or coaxial and spherical capacitor. Here we have derived inductors and types. We have seen solenoid and toroid. And we have done derivations also, so that it will be useful for ESE. And we have done some numerous number of problems on capacitors and inductors. So many number of problems we have done here. That's why this playlist is really special. Other than this, dear, the process of doing this, importantly, what the things that we have derived. Maxwell equations for static fields. Important things I am trying to highlight. Poisson's and Laplace equations. Boundary conditions. Capacitors and inductors. Mainly discussed about these things here. Maxwell equations for static fields. Equation number integral form, differential form, and source. Equation 1, integral form, closed surface integral of d dot ds is equal to volume integral of rho v dv. Differential form, del dot d is equal to rho v. Source, Gauss law for electrostatic fields. Second, closed loop integral of E dot dl is 0. Differential form del cross E is equal to 0. Curl of E is 0. Rotation of E is 0. Static electric field cannot be rotated. It's a irrotational field or conservative field. Property. Conservative property of electric field. Clear? Next, closed loop integral of H dot dl is equal to surface integral of J dot ds. Implies del cross H is equal to J. Ambience law. Fourth, closed surface integral of B dot ds is equal to 0. Differential form del dot B is equal to 0. Divergence of magnetic flux density is 0. Its divergence is 0. It's a divergence-less field. It's a solenoidal field. Source. Gauss law for magnetic fields. Or non-existence of magnetic monopole. Here also, dear, all these things we are derived. We'll see when we are dealing with CTQs, conceptual questions. If required, I'll try to derive it based on the necessity. That's about Maxwell equations for static fields. Regarding Poisson's and Laplace equations, electric fields, del square V is equal to minus rho V by epsilon naught. This is Poisson's equation. Keeping rho V is equal to 0 here. Del square V is equal to 0. Laplace equation. Del square is Laplacian operator. Magnetic fields. Del square A is equal to minus mu naught J. Poisson's equation. Keeping J is 0. Del square A is equal to 0. Laplace equation. Del square is called the Laplacian operator. Poisson's and Laplace equations. And we are seeing boundary conditions. And the boundary conditions we are seeing dielectric boundary conditions. Under dielectric boundary conditions, the first one that we got is ET1 is equal to ET2. Tangential component of electric field is continuous across the boundary of discontinuity. Unconditionally continuous. dN1 is equal to dN2 if and only if rho s is equal to 0. Normal component of electric flux density is continuous across the boundary of discontinuity if and only if rho s is 0, where rho s is the surface charge density that is deliberately placed on the boundary surface. Conditionally continuous. ST1 is equal to ST2 if and only if K is equal to 0. Tangential component of magnetic field intensity is continuous across the boundary of discontinuity. Is there what's the doubt? ST1 is equal to ST2. Tangential component of magnetic field intensity is continuous across the boundary of discontinuity if and only if K is 0, where K is the surface current. It is deliberately placed on the boundary. What is the unit of surface current here? Ampere per meter. It's ampere per meter. Fourth one. Bn1 is equal to Bn2. Bn1 is equal to Bn2. Normal component of magnetic flux density is continuous across the boundary of discontinuity. Unconditionally continuous. Unconditionally continuous. Unconditionally continuous. One second. Yeah. Second, we had seen dielectric conductor boundary conditions. Dielectric conductor boundary conditions. This conductor here is nothing but a perfect conductor. Now in a perfect conductor, as we know, the field cannot exist. This component will become 0. So what do you get here? E tan is equal to 0. Tangential component of electric field intensity on the surface of perfect conductor is 0. Second, the actual equation for this is dN2 minus dN1 is equal to rho s. When you make rho s 0, you get dN1 is equal to dN2. conditionally continuous. Now in this, if you make one of this 0, you get d normal is equal to rho s, normal component of electric flux density is equal to surface charge density. Any doubts you can ask dear. Third one, this is in vector notation. How do you get this is HT2 minus HT1 is equal to K cross AN. HT2 minus HT1 is equal to K cross AN. When K is 0, in scalar notation we get HT1 is equal to HT2. Conditionally continuous. In perfect conductor, HT1 will become 0. Therefore you get H tan is equal to K cross AN. Always remember one thing dear, magnetic field intensity and surface current will not be in same direction. The magnetic field intensity and surface current will never be in same direction, but both have same units, remember. Both has ampere per meter. The fourth one, B normal is equal to 0. Normal component of magnetic flux density is equal to 0 on the surface of a perfect conductor. This is dielectric perfect conductor boundary conditions. That's this. Then about capacitors and inductors. Which in parallel plate capacitor. Parallel plates, each of them having an area A, spacing between them S, capacitance is given by epsilon A by S. S is the spacing and A is the area. This is for a parallel plate capacitor. If you take a cylindrical capacitor or coaxial cable having two conductors with inner conductor having radius A, outer conductor having radius B, each of them having a length L. Coaxial cable, the capacitance is given by 2 pi epsilon L by ln of B by A. Then for spherical capacitor, spherical capacitor, inner sphere of radius A, outer sphere of radius B, forming a capacitor and the capacitance 4 pi epsilon 1 by A minus 1 by B. If you make the outer radius, the radius of the outer sphere equal to infinity, then this inner sphere will become isolated sphere. Substituting B is infinity, you will get isolated sphere, and the capacitance of the isolated sphere is 4 pi epsilon A. You remember here epsilon I am using because I am trying to consider dielectric here. If it is free space, you can replace it by epsilon naught. Here also there is dielectric. Here also there is dielectric. Is that clear? Similarly, if you take solenoid, inductance L is equal to N square mu A by D. And for toroid, inductance N square mu A by 2 pi R. This synopsis is very, very important here. This is what we had covered here in capacitors and inductors. With these concepts, we are done with static field theory. What we have done in time varying field theory is we try to modify these Maxwell equations for static fields into Maxwell equations for time varying fields. Let us see what we have done here. Any doubts so far you can ask? Thank you, sir. The rock star of our group. Fine. So that is what we have done. Maxwell equations for static fields. Then in time varying fields, we change these equations. Two major changes we have done. One is Faraday's law. Can anyone tell me what is Faraday's law, dear? Faraday's law. According to Faraday's law, the induced EMF within any closed loop is equal to the rate of change of flux linkage. Lambda is the flux linkage given by n into psi m. N is number of turns. Later on, Heinrich Friedrich Emil Lenz said that the induced EMF will always oppose the flux produced it. Will always oppose the flux produced it and introduce the negative sign. Substituting VEMF is equal to minus n into d psi m by dt. For a straight conductor, get n is 1, V EMF is equal to minus d psi m by dt. Later on, expanding and all, you get the modified equation. One more change is from Maxwell contribution. He changed the Ambience law. We call it also as inconsistency of Ambience law. He took the Ambience law, del cross H is equal to J, modified it into del cross H is equal to J plus JD, where J is sigma E, conduction current density, JD is displacement current density, dou D by dou T. In CTQ, I'll explain here how exactly he had changed this. So with these changes, got Maxwell equations for time varying fields. Equation number integral form differential form and source. Equation 1, closed surface integral of d dot ds is volume integral of rho v dv. Integral form, differential form, del dot d is equal to rho v. Source, Gauss law for electric fields. Remember, dot products will not change. Dot products will remain same for both static fields and time varying fields. This is a very important point that you need to remember. The dot products won't change. They remain same. They remain same for both static and time varying fields. The equation that we changed from Faraday's law is closed loop integral of E dot dl is equal to surface integral of minus dou b by dou t dot ds. Applying Stokes on LHS, del cross E is equal to minus dou b by dou t. Source, Faraday's law. Third one, closed loop integral of h dot dl is equal to surface integral of J plus JD dot ds. J is equal to sigma E, conduction current density. JD is equal to dou d by dou t, displacement current density. Differential form, del cross H is equal to J plus JD, sigma E plus dou d by dou t. Source, inconsistency of Ampere's law. It's better to put it in this way. Inconsistency of Ampere's law. I call it as Maxwell Contribution. I want to see the Maxwell name here. That's the reason I say Maxwell Contribution. Fourth one, closed surface integral of B dot ds is 0. Implies del dot B is 0. Non-existence of magnetic monopole. A magnetic monopole does not exist. They always exist in pairs. Are also called as Gauss Law for magnetic fields. This is concept through question series, Krishna. Transmission lines we are starting from Monday. That is what we have dealt in this time varying field theory. This is what we have dealt in module 1, theory or concept. Let us see some questions through which we learn concepts. The concept is done now. Let us try and attempt some questions. Transmission line, Krishna, will start from Monday. Yes, current is not a vector. Good question. I'll help you out, don't worry. And Krishna, try to understand. This is concept through question series, dear. This is not the regular GATE and ESE series. When we go for regular GATE and ESE series, that we have tomorrow and day after tomorrow, we have EM wave propagation, where we discuss about reflection and refraction of plane waves. There we can see all the new topics, and I am going to start transmission lines and waveguides also. How to prove current is scalar, as current has direction. See dear, one thing I want to tell you. You tell me what is a vector. Tell me what is a vector. Anything which has direction is a vector? No. A vector is something which has magnitude and direction, and it must obey vector addition. Now the question is, does it obey vector addition? No. That's the reason why I call, even though current is having magnitude and direction, we call it as a scalar quantity. First thing. Okay? Now let me define current in some other way. Current is rate of change of charge. Current is rate of change of charge. Now you tell me, is charge scalar or vector? That is what I am trying to tell you, dear. I is dq by dt. You are writing from so many number of days, I am right. What is charge? Is it scalar or vector? How it is scalar? The answer for that question I am trying to give. And please follow. That's okay. I will clarify, don't worry. I'll clarify, don't worry. Please follow EM wave propagation series, which is inclined towards GATE and ESE 2023. This is MCQ series or CTQ series. You will find theory redundant, okay? First advice. Second, these are for new people. Second, if you are following GATE and ESE series, follow elements of EMF theory series, which is meant for GATE and ESE 2023. Follow EM wave propagation series. Follow antennas Mahamarathon series. These three series are meant for GATE and ESE. All continuation videos in those series will be aligned towards GATE and ESE without any repetition. These MCQs, while we are trying to explain MCQs and CTQs for all the new students who have joined, we tend to have some topics repeated. Don't worry, Krishna, I'll explain, don't worry. Current is the ratio of two things, rate of change of charge. Thereby you can say it is scalar, no doubt. But this is a special case which has direction. Even though current is having direction, current is not measured in this way. Current is measured at a given point always. The amount of charge at this point, the amount of change of charge at this point for a unit time is called current. Even though the current is having direction, it is not measured in that way. It is measured at a given point always, remember. That's a key in understanding. Yes. Is that clear, Krishna? Are you into the graduation or had you completed? Hi Karna. Thank you, Krishna. And please follow EM wave propagation series, my dear. Okay. Which college? Follow EM wave propagation series. I'll make a note. You can just note down. Follow elements of EMF theory series. This is aligned to GATE and ESE 2023. All the videos that I add here will be aligned. Follow EM wave propagation series. Follow antennas Mahamarathon series. All these series are aligned to GATE and ESE 2023. 3 more series we are going to start. One on transmission lines, one on waveguides, one on optical fiber communication. This will be also aligned to GATE and ESE 2023. The extra series that we have is communications, concept through question series, antennas MCQ series, antenna CTQ series. In this series, these are not aligned to GATE and ESE 2023. These are for practice purpose. I hope you got the logic, Krishna. We are into antenna CTQ series. This is a practice series. Go to the regular GATE and ESE series, dear. You will not find any repetition of topics. This is only for students who want to practice the concepts. That is for the students who are regularly following GATE and ESE series. Is that clear? Please let me know. Is that clear? So, when you are going for communication CTQ, antennas MCQ, our primary intention is to make students aligned to GATE and ESE. So, we try to discuss some questions, concepts which you feel may be repeated because you will be watching them in GATE and ESE series. Is that clear? Which of these fields, which of these is Gauss law for electric fields? Which of these is Gauss law for electric fields? Again, concept through question. Let us discuss about Gauss law. According to the statement of Gauss law, the amount of flux cut by any closed surface is equal to the charge enclosed by the surface. Psi is equal to Q enclosed. This is called true form of Gauss law. Here psi E is electric flux related to flux density as electric flux per unit surface area, unit coulomb per meter square. If you consider a small surface area ds, the flux associated is d psi E. If d psi E is equal to d into ds, this is called scalar notation. Right, in vector notation, it is d dot ds. So, psi E is equal to surface integral of d dot ds. Therefore, we got psi E is closed surface integral of d dot ds is equal to charge enclosed. How to write charge enclosed here? If you consider a line carrying a charge Q, having a length L, then this line is supposed to have uniform line charge density rho L, which is total charge by total length. If you consider small length dl in it, the charge associated is dq. Therefore, the unit is coulomb per meter. Small length dl charge is dq. From this dq is equal to rho L dl, or q is line integral of rho L dl, relation between point charge and distributed charge. If you consider a surface of area S carrying a charge Q, then this surface is supposed to have uniform surface charge density rho S, given by Q by S coulomb per meter square. If you consider a small surface area ds, charge associated with it is dq, it is given by dq by ds. From this dq is rho S ds, or q is surface integral of rho S ds. Similarly, when you consider a volume V carrying a charge Q, this volume is supposed to have a uniform volume charge density rho V, total charge by total volume coulomb per meter cube. If you consider a small volume dV, small charge dq, this is given by dq by dv. From this dq is equal to rho v dv. Q is volume integral of rho v dv. This is how this charge and distributed charges are interrelated. So from this, charge enclosed is equal to volume integral of rho v dv. This is called integral form of Maxwell first equation. Applying divergence theorem on this, when we apply divergence theorem, closed surface integral of A dot ds is equal to volume integral of del dot A dv. Applying divergence on this, what does it mean is, A is any energy source. If you consider a closed surface, A is some energy source. The amount of energy source, like light energy or something, is kept on this surface is equal to the amount of light that is dispersed or spread in this volume. That is how divergence theorem is defined. So closed surface integral of A dot ds is volume integral of del dot A dv. Closed surface integral of D dot ds is volume integral of del dot D dv. Is volume integral of rho v dv. Removing the integral on both sides, del dot D is equal to rho v. This is called differential form of Maxwell first equation. Differential form of Maxwell first equation. Is that clear? So the question, which of these is Gauss law for electric fields? Del dot D is equal to rho v, differential form. Option A is the answer. Which of these represent conservative property of electric field? Let us see here. We know work done is equal to force into displacement. We know work done is scalar quantity. Force and displacements are vector quantities. So dot product of two vectors is a scalar. F dot L is W. Where F is the electric force, which is Q into E. Force acting on this charged particle Q in the presence of electric field E is called electric force Fe. Substituting work done is Q into E dot L. It implies, what do you mean by this work done, dear? This work done means work done in moving this charge Q in the presence of electric field E by value of L. This is called work done. This is called work done. Substituting here, W is Q into E dot dl. If you try to calculate small work done dW, it is Q into E dot dl. Displacement is dl now. Implying total work done W is equal to Q into integral of E dot dl. If you assume that an external agent is doing the work, when we assume that an external agent is doing the work, then total work done will become negative minus Q into line integral of E dot dl. From this electric potential, W is equal to electric potential V is equal to work done per unit charge. Dividing by Q, this V is minus line integral of E dot dl. This is the relation between V and E. V is equal to minus line integral of E dot dl. If you consider this line L is having 2 points A and B, then we get potential VAB minus line integral of A to B E dot dl. VAB is VA minus VB, that is moving from B to A. B to A minus integral B to A E dot dl, moving from B to A minus integral B to A, moving from B to A E dot dl. Now if you extend this up to C, then you get VAC, VA minus VC minus integral C to A E dot dl. If you extend this up to D, VAD, VA minus VD minus integral D to A E dot dl. If you extend it up to A, VA minus VA, 0. So what does it mean? When I close this loop, potential will become 0. Implies closed loop integral of E dot dl is equal to 0. Integral form of Maxwell's second equation. Applying Stokes theorem on it. When you apply Stokes theorem, closed loop integral of A dot dl is equal to surface integral of del cross A dot ds. Applying Stokes here, surface integral of del cross E dot ds is equal to 0. Implies del cross E is equal to 0. Implies del cross E is equal to 0. This is called differential form of Maxwell's second equation. Now let us see the question now. Closed loop integral of E dot dl is 0. Yes, integral form. Del cross E is 0. Yes, differential form. Del cross D is 0. Wrong. Closed surface integral of closed loop integral of E dot ds is 0. Wrong. So what are true? 1 and 2 are true. 1 and 2. Option A is the answer. Option A is the answer. Clear? Third question. Which of these represent Ampere's law in static fields? Again, let us discuss the concept Ampere's law. The advantage of CTQ series is, dear, we discuss a lot of concept or theory here. Thereby your concepts will become very strong. Ampere's law states that circulation of H is equal to current enclosed. Line integral of tangential component of magnetic field intensity around a closed loop is equal to the current enclosed by the loop. This is from the statement of Ampere's law. And current and current density are related as current density is equal to current per unit surface area. Unit ampere per meter square. If you consider a small surface area ds, the current associated is di, then J is di by ds. From this, di is equal to J into ds. This is called scalar notation. In vector notation, di is equal to J dot ds. One more example, Krishna. You are asking now why current is scalar. This is the magnitude of current that you are getting here again, which is the dot product of these two vectors, current density and differential surface area. From this, I is equal to surface integral of J dot ds, the magnitude of current. This is for open surface. When you consider closed surface, I is closed surface integral of J dot ds. Is for closed surface. Now this is closed loop. This is open loop, dear. And this is closed loop. Closed loop maximum can cover open surfaces. So this fellow will decide which formula we need to use. Closed loop integral of H dot dl is equal to closed loop maximum can enclose only open surfaces. This is surface integral of J dot ds. This is called integral form of Maxwell third equation. Applying Stokes on it. Closed loop integral of A dot dl is equal to surface integral of del cross A dot ds. This is Stokes theorem. How to understand Stokes theorem is, this is a loop L. A is any energy vector like light source. The amount of light that is kept on this loop L is equal to the amount of light that is oriented in this open surface enclosed by the loop. Are you able to understand the concept? That is how practically you need to understand the Stokes theorem. Applying Stokes on LHS, closed loop integral of H dot dl is equal to surface integral of del cross H dot ds is surface integral of J dot ds. We get del cross H is equal to J. It's called Ambience Law. This is differential form. Or point form of Maxwell third equation. Differential form or point form of Maxwell third equation. Now you tell me, dear. Closed loop integral of H dot dl is equal to I enclosed. Yes, true form. Closed loop integral of H dot dl is surface integral of J dot ds. Integral form. Del cross H is equal to J. Differential form. B is equal to mu naught H. H is B by mu naught. Del cross H is equal to J can be written as del cross B by mu naught is equal to J. Yes, we can write. All the options are true. Option D is the answer. Therefore, option D is the answer. Is that clear? Any doubts? Please let me know. One second here. Next question. Which of these represent Gauss law for magnetostatics? And if you see the concept here, Gauss law for magnetic fields is derived from non-existence of magnetic monopole. A magnetic monopole does not exist. Take a permanent magnet, that's North Pole and South Pole. If you divide this into two, again you subsequently will form North Pole and South Pole. Single pole does not exist. Now always the magnetic flux will move from North Pole to South Pole. The uniform magnetic field moving from North Pole to South Pole. Flux lines, magnetic flux of psi m moving from North Pole to South Pole. Outside the magnet, inside the magnet they move from South Pole to North Pole, forming closed loops. Unlike electric flux lines, which they don't form closed loops, magnetic flux lines form closed loops. Now this fellow is releasing psi m and consuming psi m. So what is the net flux released here? Net flux generated is 0. Magnetic flux density B and magnetic flux psi m is related as magnetic flux density is psi m by S. It's Weber per meter square, or after the great scientist Nikola Tesla, it is given in terms of Tesla. If you consider a small surface area ds, the flux associated is d psi m. So for d psi m by ds, from this d psi m is b into ds. Scalar notation, from this d psi m is equal to b dot ds. Dot product of two vectors is a scalar quantity. From this psi m is equal to closed surface integral of b dot ds. But you know net flux psi m is 0. From this closed surface integral of b dot ds is 0. This is called integral form of Maxwell fourth equation. If you apply divergence on this, closed surface integral of b dot ds is volume integral of del dot b dv is 0, implies del dot b is equal to 0. Divergence of magnetic flux density is 0, implies that b is divergenceless field, or b is solenoidal field. Or B is solenoidal field. Clear? Next question. So here let us see the option now. Which of these represent Gauss law for magnetostatic field? Closed loop integral of B dot dl is 0. No, false. Closed surface integral of B dot ds is 0. True. Del dot B is 0, true. Del dot H is 0, false. 2 and 3. Option B is the answer. This and this. Got it? So, as here what we are trying to do here is, we are trying to cover questions as well as the concept. This is purely for those who want to learn concept through questions, dear. This is different from the regular GATE and ESE series. Try to understand this carefully. Next question. Which of these are resultant of Faraday's law? Faraday's law. So let us learn the concept of Faraday's law. Faraday's law. According to Faraday's law, the induced EMF within any closed path is equal to the rate of change of flux linkage. Later on, scientist Heinrich Friedrich Emil Lenz said that the induced EMF will always oppose the flux produced it, thereby introduce the negative sign. And where lambda here is the flux linkage given by n psi m, where n is number of turns, and psi m is the magnetic flux. Substituting VEMF is equal to minus n times of d psi m by dt. If you consider a straight conductor, for a straight conductor n is 1, VEMF is equal to minus d psi m by dt. Minus d psi m by dt. Okay. From this, VEMF is equal to psi and B. Psi m and B are related as B is magnetic flux density, psi m by S, Weber per meter square. If you consider small surface area ds, flux is d psi m, B is d psi m by ds. From this, d psi m is B into ds, scalar rotation. Vector rotation, d psi m is equal to B dot ds. From this, psi m is equal to surface integral of B dot ds. Substituting minus d by dt of surface integral of B dot ds. But no VEMF, closed loop integral of E dot dl, relation between V and E, relation between V and E. And remember, now the closed loop integral of E dot dl will not become 0. Can anyone tell me why? Why it is not becoming 0? Can anyone tell me? Why it is not becoming 0? Because static electric field is conservative. I repeat it here. Listen carefully. Static electric field is conservative but not time varying electric field. Therefore, it will not become 0. It is 0 means E is conservative but time varying electric field is not conservative. Substituting closed loop integral of E dot dl is equal to surface integral of minus dou B by dou T dot ds. Applying Stokes on LHS, closed loop integral of E dot dl is equal to surface integral of del cross E dot ds. Implies del cross E is equal to minus dou B by dou T. Once you substitute here, you get surface integral of del cross E dot ds is equal to surface integral of minus dou B by dou T dot ds. Removing the surface integral, we got del cross E is equal to minus dou B by dou T. Now clearly you can see del cross E is not equal to 0 because it's a time varying field. Coming to this question, which of these are resultant of Faraday's law? Del cross E is equal to 0. No. Del cross E is minus dou B by dou T. Yes. Any doubts? Next, which of these are resultant of inconsistency of Ampere's law? To understand this, let us know what is Ampere's law and what is inconsistency of Ampere's law. Inconsistency of Ampere's law. Inconsistency of Ampere's law. According to Ampere's law, del cross H is equal to J. According to Ampere's law, del cross H is equal to J. What Maxwell has done is also called as Maxwell contribution. What Maxwell has done is he had done divergence on both sides. Del dot del cross H is equal to del dot J, but from vector identity, divergence of curl of any vector is 0. So from vector identity, you will get del dot J is equal to 0. But from continuity equation, del dot J is equal to minus dou rho V by dou T. If you are not aware of continuity equation, let me explain about continuity equation here. Continuity equation is from conservative property of charge. Continuity equation is from conservative property of charge. What is conservative property of charge is, according to conservative property of charge, the rate of decrease of charge, rate of change means d by dt, rate of decrease minus dq in by dt, rate of decrease of charge in any closed volume is equal to the net outgoing current. When you know I out decided by closed surface integral of J dot ds, relation between I and J, and Q in is volume integral of rho v dv. In this very class we had seen all this these two concepts. Minus d by dt of volume integral of rho v dv is surface integral of j dot ds, implies closed surface integral of j dot ds is equal to volume integral of minus dou rho v by dou t of dv. Applying divergence theorem, closed surface integral of j dot ds is volume integral of del dot j dv is equal to volume integral of minus dou rho v by dou t of dv. Removing the volume integral on both sides, del dot j is equal to minus dou rho v by dou t. This is from continuity equation. This is from continuity equation. So according to continuity equation, del dot j is equal to minus dou rho v by dou t. And remember, continuity equation cannot be false because it is from the natural phenomena called conservative property of charge. But here I got del dot j is 0, here I got del dot j is minus dou rho v by dou t, and del dot j is minus dou rho v by dou t cannot be false. So there must be some problem with this Ambience law. That is what Maxwell has concluded, and he had added a term called JD to it. Now again he had applied divergence on both sides. Then we got del dot del cross H is del dot J plus del dot JD. But you know divergence of curl of any vector is 0. So we got 0 is equal to del dot J plus del dot JD. From this we got del dot JD is equal to minus del dot J. Del dot JD is equal to minus del dot J. You know del dot J is minus dou rho v by dou t, substituting del dot JD is equal to minus of minus plus dou rho v by dou t. From Gauss law, you know del dot D is equal to rho v. Substituting del dot JD is equal to dou by dou t of del dot D. Implies del dot JD is equal to del dot dou D by dou t. Removing the dot on both sides, JD is equal to dou D by dou t, displacement current density. So he had modified the equation. Del cross H is equal to J plus JD. J is conduction current density sigma E. JD is dou D by dou t. Displacement current density are the current which can fly in air. Is that clear? Is that clear, dear? So, which of these are resultant of inconsistency of Ampere's law? Del cross H is equal to J plus JD. J is sigma E and JD is dou D by dou t. Option D is the answer. Try to understand here. Understanding concepts here is very important. In the name of questions, what we try to understand here is concept. So if you want a deeper, good concept, always go through these kind of series where we discuss concepts elaborately. Try to link it up with these questions. Clear, dear? So this is the concept today where we have discussed about Maxwell equations, for static and time varying fields, done numerics on that. We'll come up with some more concepts in the next session, antenna CTQ 9. Thank you all for joining. Have a great day.